Okay, now it's a pleasure for me to introduce Steven Steller to you. He's Product Marketing Manager, Analog and Interface Products by Microchip, and he will tell us about the news Microchip is showing and launching here at the Electronica. Please go ahead, Steven.
Well, thank you, Wolfgang. So Microchip is launching a new family of analog PWM controllers. Microchip is not known for analog.
That's true, yeah.
But we're very strong, obviously, in the microcontroller digital space. And this is really an opportunity, we think, in the market to expand and leverage some of the capabilities that we're developing for this market.
For this market, yeah. And why do you think it's so? It's an 8 and 16-bit microcontroller, or is it 32-bit?
No microcontroller.
It's not microcontroller?
Nope, analog based. So there is no microcontroller in this Microchip product. So that's what makes it unique from a Microchip standpoint. But from an industry standpoint, it's a very wide operating voltage. So it's higher operating voltages than Microchip has done in the past, supporting higher currents, higher loads, so a much wider variety of applications.
Can you explain a little bit more in detail the applications you are covering with your new product?
Sure. So analog has a tendency to focus on point of load, DC to DC type applications. So coming off of a 12-volt rail and powering a lot of the core rails. So 0.8 volts, 1 volt, 1.2 volts, driving embedded processors, memory, high current loads, loads that would be from 10 amps to 30 amps.
Do you see the applications more in the industrial space or also in other applications like automotive? And
wide variety. Not so much automotive, but in the consumer space certainly. A lot of set-top boxes, gaming consoles, that kind of thing. But also in the industrial space as well. 12-volt rails is really where the device is optimized because we are also releasing our first family of discrete MOSFETs. So these are high-speed, low figure of merit MOSFETs, and the unique thing about our analog controller is that it's designed to work with minimizing dead time and using high-speed MOSFETs. What that means is higher efficiencies, and what we've seen is up to a 2% efficiency improvement for low figure of merit MOSFETs.
And what are the future plans in the analog space?
Sure. There's a common theme in analog to increase our operating voltage. So this is just one of the product families moving forward with higher voltages. We just released an integrated switching power regulator operating up to 30 volts. We've just released a new op-amp family up to supporting voltages up to 12 volts. So it's a common theme within Microchip analog that we want to continue to push the voltages higher to support customer applications.
But you will remain in the lower voltages. It's high voltage, but the lower you don't go to 100. And
no. Higher is relative. You're exactly right. And from a Microchip standpoint, 5 volts has been high voltage, right? But certainly in the consumer world, industrial world, high voltage is outside of Microchip's objectives.
Okay.
Okay.
I think that's okay. Thank you very much.
All right. Thank you very much, Wolfgang. I appreciate that.